Hello everyone, and welcome to today's session where we'll delve into the fascinating world of hemolytic anemia. This condition is intriguing not just because of its effects on health, but also because of the underlying science that explains these effects. So, let's get started. Understanding hemolytic anemia. Hemolytic anemia occurs when there's a significant reduction in the lifespan of red blood cells. Normally, red blood cells have a lifespan of about 120 days. However, in hemolytic anemia, this drops to 15 days or even less. This reduction can be due to various factors such as issues with bone marrow, deficiencies in essential nutrients, or diseases affecting the marrow itself. The process of red cell destruction. In healthy individuals, red cell destruction primarily occurs outside the bloodstream in what's known as the reticuloendothelial system, which includes the liver, spleen, and bone marrow. During this process, the globin part of the red cell breaks down into amino acids. The heme part breaks down into iron and protoporphyrin. Protoporphyrin is further metabolized into bilirubin in the liver. From there, it's excreted in feces as stercobilinogen and in urine as urobilinogen after reabsorption. The iron is not wasted, it's recycled back to the plasma and bound to a protein called transferrin for reuse. When red cell destruction goes awry. Sometimes, destruction occurs inside the blood vessels, a condition known as intravascular hemolysis. This scenario leads to the release of hemoglobin into the bloodstream, which is toxic and can cause symptoms such as fever, chills, and tissue damage. It can also lead to kidney damage as the hemoglobin is excreted unchanged in the urine or broken down in the kidney tubules to a form detectable in urine tests. Signs and symptoms of hemolytic anemia. Patients might experience various symptoms, including mild jaundice due to increased levels of unconjugated bilirubin. An increased incidence of gallstones. Enlarged spleen and possibly ankle ulcers, particularly in conditions like sickle cell anemia or thalassemia. In children, bone deformities such as frontal bossing in cases of beta thalassemia major. Severe bouts of anemia caused by infections like the parvovirus, known as aplastic crises. Folate deficiencies leading to another type of anemia due to the high turnover of red cells. Diagnostic indicators. In the laboratory, hemolytic anemia presents unique features. In extravascular hemolysis, you might see normal or reduced hemoglobin levels, a high respiratory count indicating increased production of red cells, and blood cells that appear abnormally shaped. In intravascular hemolysis, expect high levels of free hemoglobin in plasma and urine, a positive test for methymalbumin, and the presence of hemosiderin in the urine. Common causes. The causes of hemolytic anemia can be genetic, stemming from structural issues within the red cells, or acquired due to environmental changes affecting the cells. These might include mismatched blood transfusions, particularly ABO mismatches. Oxidative stress in conditions like G6PD deficiency. Physical damage to cells from mechanical causes or in certain autoimmune conditions. Conclusion. That wraps up our overview of hemolytic anemia, a complex condition with a wide array of causes and manifestations. Understanding both the physiological aspects and the clinical presentation helps us better manage and treat this condition. Thanks for tuning in, and I hope you found this session informative.